So coming from 7, it's now going to go 8, 9, 10, 11, and then back into number 1 would be 12. All right? So that goes 8, 9, 10, 11, and 1 will loop back into the high point to complete that high point position. So there's our overall timing that we're going to use. So the timing chart is something that you would determine on your own later on based on how long you want something to take. So because we have drawing number 1 here and drawing number 7 over here, and we filled it in with this number of drawings, and if each drawing is shot on 2s, that means it's 2, 4, 6, 8, 10, 12, 14 frames to get to this position here. And then 16, 18, 20, 22, and back up to number 1 is 24 frames. 1 second. Okay? So we'll learn more about this as we go along, about how long things take. And this comes from everyday observation. It's something that you have to start to get used to in your own everyday life. How long does something take? Remember last week in our introductory class, we talked about stuff and all the stuff that you have to do and how you have to sort of block off time to allow yourself to do stuff. How long does it take for you to commute from school to home or home to school? Okay, that's based on a schedule. It's based on traffic. It's based on how long it takes you to walk to the bus station or the train station, how long it takes for the bus to get here, and how long it takes you to get out of the bus and walk to your classroom. Okay, so stuff takes time. And now what we're doing here is we're breaking it down into minute actions where it's a key position. So in your overall scheme of life, from the point of time when you walk out the door of your apartment or your house or residence, and you get to the bus stop, and you stand waiting for the bus, and the bus comes, and you step on the bus drives away, the bus stops, you get off the bus, you walk out of the bus, you walk to your classroom, and you're at your desk at school. That takes a certain amount of time, and there are positions that you have to place your body into as you go through that action, right? So walking from your house, you have to exit your house, and then you end up at the bus stop. There are 2 finite points in time. But as you walk out the door, you grab the door handle and you close the door. So there's a key position of the door open, a key position of the door closed. Right? How long does it take you to close that door? Are you slamming the door? Are you closing it very slowly because your friends are still sleeping upstairs and you don't want to make a lot of noise? So you close the door very, very slowly. How long does that take? That's the type of timing that we're talking about here. It's the distance that something has to move from its start position to its stop position. So as an example for the door, we could take the door from its open position and it could take this long. Starting now, going click, closed. Or it could do this. Starting now, slam. Okay? Fast action, slow action. The slower your action is, the more in-betweens you have to put in order to make that action nice and smooth and slow. The faster something is, the less number of drawings you have. So for that slamming action, I might only have 1 in-between in there, and then the closed position. So the overall amount of time that it takes would be 2 frames, 4 frames, 6 frames, which is 1/4 of a second. Slam. Very, very quick. However, this one, let's just time it out. From start, now, 1 1,000, 2 1,000, 3 1,000, stop. 4 seconds. Okay? So 4 seconds times 12 is 48 frames, or 48 drawings. So it would take 48 drawings for me to do that action of closing the door, as opposed to 3. Right? So these are some of the things that we're going to get into with our animation. So now we've got our 2 key positions. Now what we have to do is we have to fill in our in-betweens. So looking at our timing chart, number 5 is our breakdown. It's the first in-between that we're going to do. So take a blank sheet of paper, put it over top. We know what this number is going to be. It's 5, so we write 5 down here. We put a line underneath it because it's a breakdown drawing. And so what we have to do now is we have to find the beginning point, the center point of our ball up here, and the center point of the ball at the bottom. Just putting 2 little dots on there. Our path of action is a straight line, which was that crease that we put in our paper. So I'm just very, very lightly drawing the line on here. And we find the halfway point between this point and this point here. Half the distance is right there. So I just put a little dot there. So now I want to draw my circle on here, and I can do this, but I'm guessing as to the size of my ball. So what I'm going to do is I'm just going to go back to my drawing number 1, find the center position, line it up over top of that one, and trace the ball off. Now, the reason that I'm drawing the ball in a circle here is because as the ball drops from drawing number 1 down, there's nothing affecting it. Okay, some people might say, well, you have to stretch the ball out. Okay, that's only if the ball has a mind of its own and it's able to distort its own body and cause itself to stretch out into that position, right? Which in this case here, we have an inanimate ball and it doesn't have a mind of its own. It's just a ball. We're releasing it. We're letting it bounce perpetually. And so it's just a circle. Nothing is causing it to change, right? Later on, when you do some other animation, you may decide to have your character, if this was a character jumping up and down, you could decide to stretch that position because that's the character in that position stretching out. All right, so here now is where we test whether or not anybody actually practiced your in-between flipping over the week. Because now you have to check to see whether or not this is moving properly. So you grab your first sheet of paper, your in-between that you just did, number 5, between your fingers like this. In between these two fingers here, you put your middle sheet of paper and hold on to it. And now you flip your drawings. And you look to see if the action is doing what you want it to do. Okay, so here's your first little pencil test to describe whether or not the ball is doing the action that you want it to do. Okay, so this is very, very important. You got to get used to this action of being able to do this without even thinking about it. So here I am, I'm blabbing away, I'm not even looking at the paper, but I'm still flipping. Okay, it's an automatic. Okay, so remember the action is, everybody stop, because I can see people are not doing it correctly. Okay, you're exposing the top drawing first. Okay, actually we should be exposing drawing number 1 first. The bottom, top, middle. Bottom, top, middle. Bottom, top, middle. Bottom, top, middle. Okay? Bottom, top, middle. 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 Okay, you don't have to go that fast, but it's fast enough that you should be able to see it. All right? So you want to see the first drawing, drawing number 1, drawing number 5, drawing number 7. Drawing number 1, 5, 7. 1, 5, 7. 1, 5, 7. 1, 5, 7. And then you can see that the action is moving correctly. Right? This will help you to determine whether or not it's moving smoothly and it's in the correct position. Now in this case here, this is just a simple mathematical type of thing where all you have to do is just mathematically find the halfway point and trace the drawing off and you've got it going. All right, so our next in-between that we're going to do can be either number 4 or we can do number 6. Right? Number 4 is a halfway between 5 and 1. So it's basically the same as doing a halfway between number 7 and 1. It's just half the distance between 5 and 1. So we take drawing number 7 off, put it off to the side. So we've just got drawing number 1 and 5. And we do the exact same thing we just did. Put a blank sheet of paper over top. This is going to be in between number 4. We find the center point of the first ball, center point of your number 5 ball, trace your path of action, the straight line, find the halfway distance in between the two, shift your drawings over top of your original number 1 so that it's centered, and trace the drawing off. Now the reason we're doing the trace off here is because, like I said before, there is nothing that is affecting the shape of the ball. The ball is still a pure circle. So there's no reason not to trace it off. Okay? Why would you guess and try and replicate the ball in an off-center position when it's just as easy just to trace it off? Okay, might as well use the trick that you can. So again, flipping the drawings, you can see how it's closer now, so therefore it looks like it's not moving as far. It's easier to see the flipping action. Okay. Number 3 is exactly the same thing. Okay, I'm not going to do it right now. I'll let you do that on your own. But number 3 is just in betweening from number 4 to number 1. And once you've got number 3 done, in betweening number 2 to number 1, or number 2 would be the halfway position between 3 and 1. So you're just in betweening each one, right? So I'll let you fill those in on your own. Let's go over and talk about number 6. So we take drawing number 5. You don't need drawing number 1 anymore. So we've got drawing number 5 and number 7. Now the idea behind number 6 is that it's the favor to number 7. It's closest to number 7. So if you look at the overall spacing, if we just take where our halfway position is here, there's our halfway point on the one ball, here's the center of our bottom ball. If we were to go to the halfway position, the ball would be right there. But we want it close to where this one is. Okay? So we're going to put it down here. But the idea behind this is that the distance between these two drawings here is fairly large. Okay? It's like the actual width of the ball itself. Okay? So we don't want to have it just pop down there. What we want to do is we want to place the ball touching the surface but not being affected by it. Right? So we want to find this bottom point here of our ball, and then we're simply going to shift and trace the number 5 ball, lining it up along the bottom edge. So this is the ball making contact with the ground, just that very, very split second as it touches the ground, but it's not being affected by it. So we have the movement of going from the halfway position to this position here. So it fills in the space, and then what it does is it creates that cushion into the ground. So if we put these two drawings over top of each other, you can see how it's just squishing on the surface there. Right? So if I flip it now, it descends, the speed of it is greater here, but then it cushions into the ground and just has a softer impact to it. It's not as abrupt. Okay? So it just makes it look nicer when it's coming down. So this is drawing number 6. So 6 is making sure that the bottom edge of the ball is at the exact same point as the oval one. These 2 points here are in the exact same position, but the ball is just traced off as a circle. So it hasn't been affected at all. So now if I take my drawings and put them in order, and when you flip your drawings, you always put drawing number 1 on the bottom. So in this case here, I have drawing number 1, 4, 5, 6, and 7. Right? So the drawings go from bottom to top, always. And the reason for that is I'm going to show you the next type of flipping. This is called stack flipping. It's where you take all your drawings, you hold them in your hand like this, and this is slightly tricky, so I'm going to show it to you in slow motion, okay? It's like a magic trick. What you do is you take the paper, you grip it at the top here nice and tight, and then you bend the paper back, and see what happens as soon as you bend it, it begins to fan a little bit. Okay, it's not all lined up. You pinch it now in its fan position, and then release the opposite side and flip it back the other way. See how the paper now fans out on this side here? See how the sheets have fanned out there? I now grab this side and hold it tight, and I release the bottom, and watch the bottom. It fans out even more. Okay? So I just fan the paper out, and it allows me to now take the drawings and drop them one at a time, just by using my thumb. Okay? So it's like taking a deck of cards and fanning it out, and it allows you to drop your drawings down in what's called stack flipping. Okay? So once again, take the drawings, line them all up so that they're all nice and lined up. Grab the paper at the top and hold it, pinch it, roll it towards your knuckles, and as soon as you roll it towards your knuckles, it begins to fan out. You then pinch the pegs and hold it, release the top, and flip it backwards so it fans out even more. Grab the bottom, flip it away from you so that the bottom fans out even more. So now you can draw your thumbs across the bottom like this. Okay? It's just a simple little technique to get you to be able to flip your drawings evenly. Okay? So that's the other thing I need you to get used to doing as quickly as possible. So now we can pencil test just by flipping our drawings to see if they're moving accurately. Doesn't give you the proper timing because when you're dropping it, you're not dropping these at 1/12 of a second, right? You're just dropping them randomly, but it just gives you a general idea of how they move. Now sometimes, I don't know if you're noticing here, but sometimes my pegs stick. You're not doing it right now, but sometimes your peg holes there. See my pegs have stuck together, okay? So you just have to fan your paper out just a little bit more so that your pegs don't grab onto each other. It's still grabbing there. It can be slightly annoying, but eventually you'll get used to it.
Are you going to quiz us on that?
Yes. Because when I go to look at your animation drawings, I'm not going to flip it, I'm going to ask you to flip it. All right? So when you grab your stack of paper, make sure your drawings are 1 on the bottom, numbered up. Take the drawings, fan them out. Okay, here's the quick and easy way of doing it, just fanning it like this. And then you'll hold it like this in front of me, and you'll flip them down. So I'll be able to see the action of the animation. Okay? So I need you to get used to doing that as well.